arc length. We're going to be moving on to talk about linear and angular speed, but first we have to talk about arc length. We've mentioned this before. For a circle of radius r, so here's our classic picture, center to edge of circle is r, central angle, that's an angle at the center of theta, and arc length s, so this curvy distance from here to here, or in reverse, from here to here, that's s. There's a relationship between these three variables, and that is arc length, s is equal to r theta. I'm going to put a little asterisk right here because the theta, put an asterisk down here and say, this is only true if we measured the angle in radians. If you put degrees in here, it won't make any sense. This relationship only holds if we measure the angle in radians. Remember, we only have two options for measuring an angle, radians or degrees. You must put this in radians, 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 radians. We're asked to find an arc length. So we're looking for S. Tells us this problem. A circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240. We're given a little diagram. If you weren't given a diagram, you certainly could produce this. Here's our radius of 4 inches. Our central angle is 240, and they're asking for S. Well, we know that the relationship is S is equal to r theta, provided theta is in radians. We're looking for S, so S is equal to 4 inches times 240 degrees. Ah, yes, but 240 degrees is not in radians. Remember how we convert that? Pi over 180. If you're given degrees, you want degrees in the denominator. So this is going to be S is equal to 4 inches times 240 over 180 pi. So those will cancel, and we're left with S is equal to 4. Well, I can think about common factors that divide in evenly into 24 and 18, and I'll get 3. So this is 8. 3 goes into 18 6 times. So there must be something bigger as well. Pi, and of course, instead of dividing this and this by 3, I could have divided by 6. So 6 goes into 24 4 times. 6 goes into 18 3 times. So S is equal to, don't forget, the unit there is inches. Remember that if we put this in radians, when we cancel, radians are unitless. So 4 inches times unitless is simply going to give us inches. So this is 16 over 3 pi inches. And if you jam that into your calculator, you'll get about 16.76 inches. If I have the globe here, so I've tried to draw this in 3 dimensions, latitude lines run from east to west. There's that famous Jimmy Buffett song called Changes in Latitude, Changes in Attitude, when he takes his boat or his plane from a northern cold climate down to the equator, his attitude changes. So that's how I always remember it. Latitude runs east-west. And longitude lines, well, GMT, I used to live overseas and listen to the BBC radio. GMT is Greenwich Mean Time. That's through the longitude line that crosses through Greenwich in England. And so that's how I remember longitude lines run like this. Now, if I have 2 cities on the same longitude line, then they could go into the center of the Earth to create, in 2 dimensions, see that little piece of pizza there? That could be considered a triangle, right? I'm sorry, that could be considered a sector of a circle. And that means if we know R and S and theta, then this S equals R theta, provided theta is in radians, would be the formula that we would use to apply to the distance between cities, which would be on the globe, this curvy distance S. Let's assume that Miami and Boston lie on the same longitude line. They don't exactly, but for the sake of the problem, let's just say they do. Miami's latitude is 25.7 degrees north of the equator, and Boston's latitude is 42.7 degrees north of the equator. Assuming that the radius of the Earth is 3,900 miles, which is close, what is the distance between the cities? So here's what we have. We have the globe, and on this longitude line, say this is the equator, and there is the center of the Earth. Now, to go up to Miami, we have to go up 25.7 degrees. So this angle here is 25.7 degrees. To go up to Boston, we go up more north. So this angle here is 42.7. What we're interested in is that angle, which is the difference. Boston, 42.7 degrees minus Miami, 25.7 degrees, will give us about 17 degrees. So Boston is 17 degrees north of Miami. So this is our theta in degrees. They tell us that this is 3,900 miles is R. So what is the distance between these two cities? Hopefully you can see that's the curvy distance on the globe. So that is S. And S equals R theta will govern our problem. So if we know that S is equal to R theta, then S is equal to 3,900 miles times 17 degrees times, well, that's in degrees. And this formula, S equals R theta, only works if our angle is in radians. So we have to multiply by pi over 180 degrees. Notice when degrees cancel, I'm left with radians, and radians are actually unitless. So that's why I put them in parentheses here. So miles here times unitless will give us miles. S, when I crunch all the numbers, I get S is approximately 1,157 miles. So there's an application of this S equals R theta.